Okay, here's the next part of this lab. One of the things I've been telling you in the other two parts is that you're going to have to get rid of the magnetic field of the Earth in order to get the true magnetic field of the wire. So I'm going to show you based on my data here, and I'm going to show you how to create a calculated column in Logger Pro to do that, and how those are defined. So let me go ahead and just bring my Logger Pro up. You can see that I've done 3 data runs so far. Run 1 is for 1 centimeter. Run 2 is for 3 centimeters, and run 3 is for 5 centimeters. I haven't recorded the fifth 5 centimeter run yet. So here is my Logger Pro window. So I'm bringing my Logger Pro window in, and as you can see, the setup of my spreadsheet is I have the distance away from the wire, that's Z in centimeters. I created a calculated column in Logger Pro to calculate the distance in meters. Now this is really easy. You go into Data, create new calculated column, and you say that this is, I want to say this is distance Z in meters. Short name is D, and I'll call it, or let's call it Z instead. Z and units of meters, and down here in the field where it says expression, I'll click in there, and what I have to do is I want to convert my distances into meters. So what I'll do is I'll just take my column, since it's in centimeters. Remember that 100 centimeters is equal to 1 meter, so I have to divide this column by 100. So I'll take this distance and divide by 100, and there you have it. Now I would click done, except I already have that column set up, but you click done and it will show up, and you enter your distance values in, and it'll automatically convert it. This is an example of how to set up a calculated column in Logger Pro. Now the important columns are going to be the BX wire, BXW, BYW, BZW, and MagZ. The reason for that, those are going to have to be calculated columns which are actually going to get rid of the magnetic field of the Earth that is showing up here in the measurements. So here's my BXM. That's the measured value that I got from the first graph in my IOLab software. So I have 125.944 minus 125.944 microteslas. The magnetic field of the Earth is 98 minus 98.466 teslas, so microteslas. So I'm going to have to subtract this value, BXE, from BXM in order to get BX wire. Now I already have that column set up. I'll show you the definition. So here's the column properties, and here's the column definition. BXM minus BXE, where I'm basically using the columns, as you can see here. I'm using BXM, which is the magnetic field that was measured, minus the magnetic field of the Earth. And you can do that for each of the components, and you have to do that for each of the components of the magnetic field, because there is going to be changes, as you already saw in the previous part, and that will affect your measurements. So in the next segment, I'm going to show you some completed data, and I'll show you how to curve fit and actually do some analysis of the data.